Okay, good morning everyone. Today we're looking at Unit 7, Lesson 3, Volume of 3D Shapes. So I'm starting with the formula sheet on this lesson because in Lesson 2, if you watch that video, it recorded and exported a little strangely. So I wanted to put the formula sheet at the front so we could talk about it and then we'll get into the note. Okay, for volume today, when we're trying to calculate the volume of a 3D shape, the way we do it is we're trying to figure out how much will fill up that 3D space essentially. Okay, surface area are the sides of a 3D shape and volume is the stuff that you can fill up inside of it. So the way we calculate the volume of any 3D shape is that we take the area of the base and then we multiply it by the height. Because for example, if you thought about having a cylinder, so if we had a cylinder, something like that, and we took the area of the base, right? That means we're calculating how much it takes to fill in this circle, and then we multiply it by the height. That is saying how many of these circles could I stack on top of each other, right? Whatever the height is, to fill up that cylinder. So by multiplying by the height, you're filling it with all those base-shaped cylinders all the way up. So that's why we calculate the volume that way, okay? So just a little bit on volume, but I want to look at your formula sheet. So that's the general rule, is that whenever we're trying to find volume, we're going to do area of our base times height. You can see that for cylinder. You can see that for cone, you can see that for rectangular prism. Area of base times height. You can see that for triangular prism, right? Area of base times height. You have a couple 3D shapes where the formula is a little bit different, where you're going to take the area of the base times the height and divide it by 3. Okay, a cone is just basically a third of the size of a cylinder, so that's why we divide it by 3. A pyramid is the same thing. You're going to take the area of the base times the height and divide it by 3. Again, that's because that's just a third of the size of the rectangular prism. Okay, and then the last shape that has a little bit of a strange formula for a sphere, volume is 4/3 pi r cubed, or if you prefer 4 pi r cubed divided by 3. All right, so the process is the same, and then understanding what the area of the base looks like is kind of up to you. Of course, you can always refer back to this formula sheet. So you should hopefully start to recognize what is my base shape. So for a cylinder, my base is a circle. So the area of a circle is pi r squared. Okay, if I look down here at my rectangular prism, my base is a rectangle. So the area of my base is that length times width. All right, for a triangle, our base is base times height, or in this case they say leg because they don't want to have two heights in the equation, divided by 2. Okay, so we're always taking the area of that base, which should pull in our previous knowledge of area. Okay, the same is true for cone and for pyramid. You can see that my base is still a circle for a cone, and that my base is still, well, in this case, a square. Right, we could do length times width or just that length squared or base squared, okay? And then your sphere, like I said, is a little unique, but you can always pull from this formula sheet when you're trying to calculate volume. So let's take a look at that note for today. So there are a number of real-world applications, again, involving the volume of 3D objects. In particular, we're gonna pay attention to prisms. So for prisms and cylinders, the volume can be found by multiplying the base area by the height. So multiplying the base area by the height. Okay, volume of a sphere, like I said when we were looking at that formula sheet, is a little bit unique. So volume of a sphere is 4/3 pi r cubed, and there's a whole proof that goes into that volume as well, but you don't need to concern yourself about that. So if we were to find the volume of this kind of odd shaped, almost cloud-like looking 3D shape we have here, we always want to take area of base times our height. So in this case, this highlighted part in blue would represent our base, and the 5 would represent our height. Put volume. So volume equals the area of my base, which is 32, times my height, which is 5. So the volume equals 160, and the units here is meters. And when we're multiplying a squared unit by a unit to the power of 1, think to your exponent rules, we'd add those together. So you're going to have a power of 3 for volume. Okay, let's look at some of the other examples here. So in particular, prisms and cylinders. So here with a cylinder, my base shape is a circle. So the volume is going to equal area of a circle times your height. And if you have trouble remembering that, the area of a circle is pi r squared, and again, times our height. Well, we first have to identify what's our radius. So our radius is going to equal 3. So we'll plug that in. And then 5 is our height. So volume equals pi times 3 squared times 5. And when you calculate that in your calculator, you should get 141.4 centimeters cubed. All right, this next example, we have a square-based prism or a rectangular-based prism. So my base shape is this square, and our height is there. So a volume in this case will equal the area of my base, so the area of a square times your height. And again, you can pull that from the formula sheet. So it would be length times width times height. So we'd have 4 times 4 times 5.5, which is 88. Our units are inches. Make sure you put it to a power of 3. All right, let's look at some more. So a sphere, this is that strange one we were talking about. So volume of a sphere, you can always refer to your formula sheet for these, 4/3 pi r cubed. We have to determine what is pi, what is r. We know our diameter is 24, so our radius is just going to be half of that. So our radius will be 12. So we'll plug that in and then calculate our volume. So 4/3 pi 12 cubed is going to equal 7,238, .2, and again we have inches cubed. Okay, this next example we'll talk about the setup, and then I'd like you guys to give it a try. So it says a propane tank is in the shape of a cylinder with 2 hemispherical ends. The length of the cylindrical portion is 85 inches, and the inside diameter of the tank is 25 inches. Determine the volume of propane in gallons that will fit inside this propane tank. So first we have a cylinder, right? If we wanted to look at this, we have a cylinder here. This is kind of like a side view of the propane tank you should think about. So we have this cylinder. And then we have 2 hemispheres on either side. So we have a hemisphere here, and we have this hemisphere here. Okay, if we were to cut those 2 off and try to, put them together, we would just have one sphere. All right, so we have a cylinder and we have a sphere that we're basically trying to find the volume of, and we're going to have to add those together. We can put some measurements on the sphere because we should know that the diameter is going to be the same as the diameter of that cylinder. So our diameter is going to be 25 inches. Okay, so when we go to calculate our volume should be equal to the volume of the cylinder plus the volume of the sphere. Okay, so pause the video and see if you can work through finding each of those volumes and then adding them together to give you your total volume for the propane tank. Okay, so there's your solution for the volume of the propane tank. We took the volume of our cylinder, all right, and the volume of our sphere. So you can see that for our radius was half of 25, so we plugged in that 12.5. For the volume of the cylinder, and we also need that 12.5 for the volume of the sphere. When you add those values together, you should find that the total volume is 49,905.5 inches cubed. Don't forget to have a power of 3 when you're doing volume. And that's it for your note for today.